So here's another sample problem for trig triangles, and you can see that we have square roots, so we can already know, well, we might want to try to use trig triangles to solve this. So our square root is in the form of a squared minus x squared, and if you saw my last video, you can know that that's the equation for the length of a leg of a triangle with hypotenuse of a. And in our case, our a is going to be 4. So if we do our first step of filling in our triangle, well, we know our hypotenuse is 4, and the leg, one of the legs is going to be x, and then finally the last leg is just going to be this expression right here, 16 minus x squared. So now let's go ahead and solve for x and dx. So we have this x here, and we don't want to use the square root. So sine of theta is equal to x over 4, so x is equal to 4 sine theta. And once again, that follows the form of a sine theta when we have the square root of a squared minus x squared. And now we just solve for dx, and that's going to be 4 cosine theta d theta. So next step is to rewrite the integral. So we have an x cubed on top, so we're going to have a 4 sine theta cubed. I can go ahead and write that 4 cubed times sine cubed of theta. And then we're dividing that by square root of 16 minus x squared. Well, cosine of theta is equal to square root of 16 minus x squared over 4, so square root of 16 minus x squared is equal to 4 cosine theta. And never forget your dx, which is 4 cosine theta. And once again, some nice canceling goes on. So let's rewrite that, and we gonna take this constant outside, so we have 4 cubed times the integral of sine cubed of theta. So in the last video, or d theta in the last video, the integral turned out pretty nice, and in this video it doesn't. And many times it's not going to turn out pretty nice. So let's figure out how we can integrate sine cubed theta. Well, lots of times when we have odd powers of a trigonometric function, we're going to rewrite it as this. And then the next thing we can do is use one of our trig identities, which is that sine squared theta is equal to 1 minus cosine theta, because sine squared plus cosine squared is 1. So, that's going to be 1 minus cosine squared of theta. And from here, let's just rewrite that. So we have 4 cubed, the integral of 1 minus cosine squared theta times sine theta. And this is good because we got a cosine theta and a sine theta in the same expression. And you can use a u sub when you have a function and its derivative, because the derivative of negative cosine is sine, and sine is cosine. So let's do a u sub, and in this case, the best way to go would be having u be cosine theta, and du in that case would be negative sine theta. but we have positive sine theta, so we're going to go ahead and multiply each side by -1, and we get sine theta is negative du. So let's rewrite that. And then we just get the integral of 1 minus u squared du, which is pretty easy to integrate. So we have 4 cubed. And the integral of 1 in terms of u, well, that's just u. And, what I forgot here is this negative sign, because we have negative du equals sine theta. So I'm just going to go ahead and pop it out there. When we were doing the u sub, sine theta is negative du, not du. So we get -4/3 times the integral of 1 minus u squared du. So a negative there, and then we would have a negative there. Okay, and so where were we? We had the integral of 1 in terms of u, and now we have the integral of u squared in terms of u, and that's just going to be u cubed over 3. And remember, we don't have limits, so we're going to add c. So now we have a lot of backtracking to do, because we have to substitute cosine theta in as u, and then we have to substitute x's in terms of thetas. So let's start that. So our u is cosine theta, so we have -4 cubed times cosine theta minus cosine cubed theta over 3 plus c. So let's go back to our problem and write what we got, which is that. So -4 cubed cosine theta minus cosine cubed theta over 3 plus c. And then remember, the last step of a trig triangle is to substitute these x's into thetas. So cosine theta, well, what is that in terms of our triangle? Cosine theta is going to equal, well, that's simply adjacent over over your hypotenuse. So cosine theta is equal to, adjacent is square root of 16 minus x squared. And then our hypotenuse is 4, so we're going to divide here by 4. And now we got to plug this in here, and we get a final answer of -4 cubed times cosine theta, that's just this, so square root of 16 minus x squared over 4 minus cosine cubed theta over 3. I'm going to pull this over 3. I'm going to write that as 1/3. And then in brackets, cosine cubed is just going to be square root of 16 minus x squared, because that's over 4. That's cosine. And that needs to be cubed. And so there's a good example of how trig triangles can get really messy, but we did get a final answer for this integral.